So today we're going to talk about compound interest. We're first going to do a quick review about percents. And let's say you were going to buy something for $100 and the tax was 8%. Now usually what we do is we say, well, we're going to pay the $100 and then we're going to figure out 8% of 100 and add that on. So that turns out to be 100 plus $8, which gives us a total of 108. Now there's another way of looking at this step right here, the first step, the 100 plus 100 times 0.08. We can factor out this 100. It's in this term and in that term. So we take out the 100, we're left with 1 plus 0.08. And you check that and see if you distribute the 100 to the 1, we get 100, and 100 to the 0.08, that's what's written right here. So if we combine what's in the parentheses, we get 1.08. And 100 times 1.08 is 108, which is the same answer that we got up here. So it's just a different way of thinking about percents. Rather than finding a percent and adding it onto the original amount, you can take the original amount, multiply it by 108% to find your final amount. So with that in mind, we're going to think about a little investment. Okay, we are going to walk into a bank. We're going to call this year 0. And we're going to deposit a certain amount, and we're going to call that amount P, which stands for principal, and that is the initial amount that you invest. Now after 1 year, the bank is going to give you some interest. So you're going to have your initial amount that you deposited, and they're going to add a certain percentage of that amount. So we call that P times R, where R is going to represent the interest rate. Now if we factor out like we did on the previous page, we can make this P times 1 plus R. So you see the same thing in general that we have here, that we had on the previous slide, is we've got our principal here times 100 and R%. So that's what we'd have after 1 year. Now after 2 years, we would have this same amount here, but we would earn interest on that. So we would have 100 and R% of the amount after year 1. And we can simplify this expression just like that. Now after 3 years, we would have this amount, P times 1 plus R, times 100 and R%, and we can simplify that. And you should be seeing a pattern here, right? We've got the 1 plus R cubed, 1 plus R, 1 plus R to the 4th power. So after n years, or maybe we should say t years, we would have P times 1 plus R raised to the t. And notice that what we have is a variable in our exponent, which makes this an exponential function. So let's use that formula to find an answer to that question, or this question. We've got A, our amount, equals the principal times 1 plus the interest rate raised to the number of years. So we're depositing $100, that's our principal. So let's see, we've got equals 100 times 1 plus. The account earns 1.2% annual interest. Now when we operate with percents, we've got to make that a decimal. So 1.2 looks like 0.012 raised to the t, 15 years. So t is 15. So this we're going to do in our calculator. Be careful that you follow the order of operations, but we should end up with 119.59. Now we're dealing with money, so we'll round our cents to 2 decimal places. And that's our answer. So you see we've got 1.2%. We leave $100. After 15 years, we've earned $19.59 interest. Now I just wanted you to see the graph of the function that we just used. We just used y equals 100 times 1 plus 0.012 to the t. So if we graph this on our calculator, this is what it would look like. And you'll see that it is exponential. You see how it increases very rapidly up here. We've got this asymptotic behavior down here. And you'll notice a few features like the y-intercept is at 100 because that is our principal, that's our initial amount. And in the problem we just did, we were looking around what happens after 15 years, around here. So that would be our $119. But if you look after 100 years, we're going to have over $300 in that account. And the more years we leave it in, the more it's going to grow. Now, interest is not always posted annually. Sometimes banks will post it 4 times a year. So they divide that 1.2% into 4, and which means we have to change our formula a little bit. So the one we were using looked like this. And this works perfectly if they compound the interest annually, once a year. But if they post it quarterly, we have to change a few things. Our interest rate would be divided by 4, because quarterly means 4 times a year. And now we've got to raise that to the 4t, because they're posting 4 times a year. So for this particular problem, we have P, 1 plus our interest rate is 0.012 over 4, raised to the 4 times 15 years. Now be sure when you put this in your calculator that you use parentheses for your exponent. Otherwise they're going to raise this just to the 4th power and then multiply the whole thing by 15. So your answer, when you put that in your calculator, should be 119.69. Now notice there's a difference. In the problem where we did the interest compounded once a year, we had $119.59. So if they compound the interest 4 times a year, we end up with a little bit more. Now this difference here between 69 cents and 59 cents may not be all that significant, but if you imagine instead of depositing $100, if we invested $1 million, this difference would be much, much more significant. Now we can look at interest compounded as frequently as we want to. So this problem was compounded quarterly, but what would happen if we wanted to compound the interest monthly? Our formula would be very similar, except 1 plus r over 12 times a year raised to the 12t. So that would be 100, 1 plus 0.012 over 12 to the 12 times 15. And that's going to give us 119.71. So again, see, the more compoundings, right? It's still 1.2% interest annually, but the more times they give us our interest through the year, the more money we're going to make. Here we had annually, here we had quarterly, and this is what it would look like for monthly. So here is our summary. You might want to write down this formula, make sure you memorize it. But we've got A representing our amount in our bank account, that's our balance. P is the principal, that's our initial investment. R is the interest rate, and remember that's got to be in decimal form, not as a percent, in decimal form. N is our compoundings per period, which in our cases will be per year, and T is the number of years.